Okay, so previously what we covered is, just to recap, the first equation that you learned last week is F equal to KD. F equal to KD. The shape of the bracket that you use must be carefully used. For the F and displacement, the force and displacement, you use curly form. For the stiffness matrix, you use a square bracket. So this is the first thing that we learned last week. And then there's a difference between capital F and small f. So if you're dealing with a individual element, then you use a small f and small k. And if you deal with the whole structure or in the global dimension, then we use a capital F and capital K. So these are the differences between the symbol and how you write. And we have proved to you how we arrive by looking at this diagram on the left hand side on your screen. The spring structure with 2 points with the forces. Small f means internal forces. The forces on the left hand side, point 1, F1x and F2x, and the displacement at point 1 and point 2 we write as U1 and U2. And then we already proved to you how we arrive at a form F equal to KD. So for a normal case, all right, for a normal case, if you have a tensile loading, you're pulling at both ends. Okay, if you have a tensile loading, you're pulling at both ends. You will be arriving at this matrix form, right? You'll be arriving at matrix form F1x, F2x on the left hand side. Your K matrix will be K minus K minus K and K, and U1 and U2. All right. So what is important from the previous lecture is that you must know how to derive this matrix form. Okay. What happens if become a compressive? What happens if your force going in? Then you can no longer use this matrix. We have to derive from the equation by following these slides. So you have to start with the force and then you derive. Okay, so for this module, finite element analysis is the application of what you learned since your first semester until your year 3 module. Okay, yeah, right. So general form for the matrix form is this one. The one on the right hand side of your screen. The general form will be F1x, F2x, K. You have 4 number of K there, and then U1 and U2. Okay, so this is what we cover in our previous lecture. Now today we're going to look at one example. Okay, we're going to look at one example using these 7 steps. Just recap, what are the steps? First, you select the element type, meaning you select the point that you want to use for selection, or you do discretization, you do meshing first. Okay, you do meshing, you do discretization, means you break the element into a few points. Normally we break into 2 points, 3 points, and even 4 points. So the basic one is 2 points. So you break into 2 points. Then after that, you call out a function that related to the element itself. So spring structure is F equal to Kx, this kind of equation. Then after that, you derive the strain-stress displacement or stress-strain relationship for the spring. Then after that, you solve for the matrix equation. You derive until you get this kind of form. And you combine them together. You will get the capital K, because previously, before step number 4, you are seeing the small k. You are seeing the small k. It is the local stiffness matrix or element stiffness matrix. You only look at element. Then you combine into a global one. You have more than one element. If you have more than one element. Okay, then you solve for the unknown. So today we look at how we apply these 7 steps. Now this question will be similar to your tutorial chapter 2. You can find this question. So stop me if you're not able to understand what you see on the screen here. So if you look at this diagram, you are having 0.1, 0.3, 0.2. And then you have a symbol of 1 and 2. It means that if you're seeing one circle, it means the first element. Two circle, it means you have two element or second element. Okay. Now, first element is connected by, the first step is that you do discretization, means that you're having a few node. The simplest one is 2 node. So for element 1, you're having a node 1 and node 3. Position 1 or 0.1 and 0.3 that tell you what is happening to the element 1. Element 2 consists of 2 points also, but the point number is 3 and 2. Okay, 3 and 2. And K is the stiffness matrix for K1, it means for the element 1. K2 is for the element 2. Then you are given the general direction of X positive here. And inside this structure, you're having an external force. If you see the capital F means external force. In the global scale means you apply loading on the element itself. So as you can see here, you are having a 2 capital F here. So one at the point number 3, so you write, or the question will give you F capital F 3x means force, external force at point number 3 in X direction. And there's a force, external force at point number 2, denoted by capital F 2x. So this scenario gives you 2 spring assembly system. Any question on the diagram? Any question?
No, sir.
No, okay. Who is answering just now? Chia, is it? Chia or Su?
Me, sir.
Okay, Chia.
Yeah.
Okay, Chia. Just to test whether you understand or not. Okay, by looking at the diagram on the right hand side.
Okay.
So what is how many spring number 1? String number 1 is connecting point, which point? Point 1, point 1, 3, and 2. Which one?
Sorry, sir. Sorry,
Element,
sir. Okay.
yeah, spring number 1 is connecting which point?
1.
You're seeing a few points there, right?
Yeah.
Yeah, so it's connecting, spring number 1 is connecting which point?
Point number 1.
And
3.
3. Okay, good. How many forces you have in the system? How many external force you have in the system?
External force.
Yeah.
F2. 1, 2, 2.
2 forces. Okay, good. Yeah. So you're able to understand the diagram. Okay, let's continue with the question itself. So the question asks us to determine the local structure, the total structure stiffness matrix, means that we're going to find the K matrix. The K matrix. All right. For spring assembly given below by using force displacement matrix relationship. Okay. Now, before we start, I want to just to test whether you understand or not. Ashma, are you there, Ashma?
Yes, sir.
Ashma, what is the equation that that you learn? What is the equation when it come to this module? When it come to derive the stiffness metric, what is the first equation that we always mention?
F equal to KD.
Okay, correct. So we are going to start with that equation. All right.
Mhm.
So yeah, we continue with the discussion for this question. So if you look at the diagram, if you're seeing this symbol at point 1, you see there's a line and a slanted line here, means that point 1 cannot move. It's a fixed point. It's a fixed point. So if you're using ANSYS software or other simulation software, when you do the boundary condition setting, so point 1 cannot move. It's a fixed point. It's a fixed point. So fixed point means that point 1 cannot move. If point 1 cannot move, means no displacement. Okay, no displacement. So axial force for F3x at here. So we have axial force F3 at point number 3 and axial force F2x. Axial means along the axis. Axial force is along the axis. So in here, you're given the x-axis. So this F3x and F2x is along x-axis. Okay. All right. And then, yeah, so x-axis given, we have to understand that x is the global axis. It's a global axis. So let's look at individual element. So if you look at element 1, mean that you're looking at one circle, right? Means that point 1 and point 3, K1 and F3, that related to element 1. So how do we write? First one, you use the general equation, F equal to KD, that we derive using the tensile loading scenario. Meaning we assume there's a force coming out from the structure, and we can use F1x. F1x means point 1 in x direction, and above this one, the superscript here, this one bracket, or this symbol here, it means that it refers to element 1. Okay, so today we add on a little bit from what we learned previously. So if you're referring to this point, since you're having two elements, we need to carefully denote or write your equation correctly. So if you're referring to first element, point 1, so you write F, and we look at element, so we use a small f, small f, sub 1x, and then on the top here, we write 1 bracket. Okay, 1 colon or something. So 1, close it. And then below there is the next point, which is F, which is your point number 3. Since we are looking at element dimension, we write small f, although there's a capital F here. So at this moment, we do not consider the capital F first. We look at the element. So we write F, point number 3, so F3x and 1. Remember to write the 1 here. Means that because you're having two elements, you don't want to confuse your number. All right? So you complete the left-hand side with the force alphabet equal bracket square with the K. So you have K1 positive, negative, negative, positive. So you have K1 minus K1 minus K1, K1. All right. So this one fixed already, for spring structure, fixed already. And you need to change the displacement format. So point 1 is going along x-axis. We are referring to x-axis, so you write U1, point 1, and then top there you write 1, and then you close it. All right. So U11, it means that element 1, point 1. Okay. Then same with the point number 3. Point number 3, because it's moving, is the displacement of element 1 is moving to x direction. So you write U3 and then 1. So if this one is come out in your exam, so this formula will give you 1 to 2 marks. If you write this equation correctly with all the notation, you will score at least 1 mark in your answer. All right, so take note on that. Any question on the notation? Brian, you understand? You understand the formula that you see on your screen?
Yes, sir.
All right, excellent. Anyone, if you do not understand, please stop me. I can explain one more time. Don't let the information pass by.
So just
Yes.
to clarify,
Yes.
right? The number 1 in the bracket is the point of reference, right?
You mean this one? You mean this one, is it?
Yeah.
So this one is refer to element. You have two spring here. It means that you refer to the first spring.
So means what I refer to, right?
Yes, yes. You refer to the first spring here.
Okay.
You write 1. If then I show you the what happened if you accidentally write as 2. So if you're referring to element 2, okay. So element 2, okay, Chia, can you answer what is the F element here? If you're referring to 2, how you write the element 2 F actually?
Okay. So element
F what? You have 2 F there, right?
F
Element 2, you have 2 points, so you have 2 F there. So the first one
F2x.
is F2x, 2x. This is what you have to refer to diagram. The first one, you have to refer to the point, that first one that you see here.
So it's
What is
F3.
F3 what? F3x.
3x. The
And then
bottom one is F. Then 2.
top one, you have to close it. You have to close it. Okay, the bottom one.
F2x.
F2x. Top one is 2. And equal. Okay, Chia, you have done with the question. It's good. We're going to ask the second person. Okay, second person. Sue, is your mic working? Sue, is your mic working?
Yes.
Okay, Sue, what is, by comparing the answer that you see on the screen here, if you look at element 1, you
Yes.
have K1 minus K1 minus K1 K1. So what do you think? You should fill in the matrix parking lot here. What is the value for this one? Or what is the alphabet, or you should write here?
K
K1.
K2
K2. This one?
minus K2
Okay. I think you managed to get it. This one?
minus K2 and K2.
Correct. Okay. Okay. Let me ask the next person. Next person will be Chia, I already asked. Sue. Sue, are you there, Sue?
Yes.
Sue, I just asked you. Okay. Ashmal. Ashmal, are you there?
Sir.
Okay. What is the displacement here? How do you write?
Yes, sir.
Yeah. What is the answer for this one? What should you write here?
U3.
Again?
U3.
U3. And then the bottom one?
U2.
Okay. You have
U2.
U3, and then this one 2. You must write this one, then U2, and then 2 here. Okay, this is 2. Okay, so all of you able to manage to capture the concept. So as long as you know how to write this one, so this one give you 1 mark, this one give you 1 mark. So it's very easy to score. As long as you know what you're doing, then you are able to score marks very easily. Okay. So I show you the answer. So this is what we all agree just now. So just remember, you have to know how to write, and then be careful in the bracket. The form of the bracket, sometimes the student panic in the exam. So you will accidentally write all the bracket become square bracket. So you will get the wrong answer. Okay. It represents a different thing if you use a square or curly bracket. All right. Then after that, we need to combine. We need to combine these two metrics together. So you need to know that matrix actually is a parking lot. It's a parking lot. So I draw just a draft for you so that you know how to park all the number. So you know that in matrix you can break into their level and column. So you have to know that if you write 1, it means that this is level 1. This is level 3. If you write 3 there, it means it's level 3. Then this is 1, 1. This is 1 also. So you have to know that this number is these two number refer to element 1. These two, element 1. This one refer to your point number 2 here. This is point 3. Or I can say that this one refer to point 1. This one refer to point 3. This one refer to point 1. These two. And then these two refer to point 3. Okay. So this one follow. This one, this number is point 1. This number is point 3. So this one also same, the below one. So this one, the top one is point 3. This one is point 2. And these two number here, this row is referring to point 3. This one referring to point 2. And then the top one is 3, 2. This one is 2. Sorry, this is 3. This is 2. Okay, so you have to know the parking lot itself. Then we will pull them all together into one single matrix. Okay, all right. So I continue with all the slides here. So we combine. Okay. Before we combine, you must look at the diagram itself. As here, you know that spring 1 and spring 2 connected at point number 3, and the loading is carried together at point number 3. So we will assume one concept. We will use continuity concept so that we're able to continue to process this one. Okay, we will assume point number 3 is having a continuity, is meeting the continuity requirement. Meaning, if you pull at point number 2, point 3 will move along, and then it will affect displacement at point number 1. So the principle is called the requirement that allow us to continue is we will use the continuity or compatibility requirement. Okay, if not, if you do not apply this requirement, it means if you pull at point number 2, then it will break away. Okay, okay, let's continue. Now, what does this continuity requirement mean? It means that whatever you move in any point here, it will affect. It will affect. So it means that movement at point number 3 will be the same in the case of element 1 and element 2, mean that this number U31 will be the same as U32, which means the meeting point of these two elements. Okay, these two number will must same. Must same. So if this one, in this matrix, you get one number for U3, this number you can straight away substitute inside here. Or if you get this one, you can substitute inside here. Because we are using continuity requirement or compatibility requirement. Okay, so this is a concept we will not mention in the test, but you have to know. So every time you have a spring structure or a beam that connected together through a sharing point, then we will use continuity requirement to continue with our analysis. Okay, means it link together. All right, we continue. Oops. Okay, so free body diagram. Okay, let me explain the free body diagram first. So if you break the free body diagram, you break the system into small point. At first, how you begin. Now, normally it's very hard to tell the direction of whether going in or going out. So what I propose is I will start with one point that with a clean forces. In this case, I will start with this point. If you look at point number 2, you having, let me draw, this is point number 2. If you have an external force pulling at this direction, capital 2Fx to the right. So to balance this point, it must have a counter force in another direction. So you can draw the first diagram, the first free body diagram with this one. Okay, so any question for the first free body diagram at a node? You start with node number 2 because it is the most simplest one. Of course, you can start with point 1, but later you need to link all the force together. So I would propose to start with one end that open, or there's one point that give you a confirmed answer. So this one, you start with F2x direction, then you counter the direction. Means you draw this one. Then you continue. Okay, then you continue. Then after you done this one already, then you continue with element 2. So you extract the element 2 out from the body. Okay, apologize for my drawing. I'm drawing using my mouse. Okay, so this is element 2. So element 2, you take what you draw just now. So element 2, point number 2 give you this direction. So this point must counter this force. So for element 2, the force on the right hand side will go this way to counter the force that you draw just now. Okay, now this force is point number 2. So because you're looking at this element, that's why we denote this force with F, small f, 2x in this direction. Clear? Every one of you? This seems logic to you. It must make sense to you. So why this suddenly arrow is pointing to the right? You derive from the point number 2 here. Okay, it must counter the direction. Okay, now then you continue with the element 2. You have one more side on the left. So this element must balance. You are pulling on the point number 2 here to the right. It must balance. So there's another force counter the direction. So the direction is pointing to the left. But however, if you look at this diagram here, is pointing to the right. Okay, pointing to the right. So maybe for this case, we will stop for a while. Then we will judge based on the logic that we can derive from here. Okay. Then we try to solve from another side. Solve from point 1. So point 1, you imagine you have two forces that pulling to the right. You are pulling to the right. So if you are point 1, and you stick to the wall, you will feel that you are pulling towards right hand side. There's one force that pull to the right hand side if you are at point 1. So we can draw for point 1, the arrow is pointing to the right hand side. So to counter this force at point 1, we're looking at point 1. So they must be opposite forces for point 1. Okay. So, and then we denote this one. Okay, notation later I'll come and explain about this one. So the force that acting on the wall, because under the effect of capital F here, you have two capital F there, external force. So F2x and F3x. So when you pull the external force, something must be filled by point number 1. So the forces that feel by this point here, we can write as capital 1, capital F1x, because it's reacting to these forces. This one you won't see in the question, but you have to know, you have to smartly can see that this point you're having a reaction force because of these two capital F. Try to differentiate between the small f and capital. So for point 1, because under the capital F reaction, you are having a reaction force that counter these two. Okay, that counter these two. So you're having a F1x here. This one you can write as F1x. Okay. All right. Then you continue with the second the element. Then you draw element 1. Okay, again, I apologize for my bad drawing. So this is point 1. This is point 3. So to counter this force, to counter the force at point 1, it must be opposite direction, going this way. So this is small f1x here. And then point number 3, it must be, you must be careful. You must be careful how you draw the number 3 here. So number 3 here, it will be a bit confusing because it's connecting element 2 and element 3. Now by logic, it should go inside here. By logic, it should go this way because it's counter this one. So let me pause it a while. Then we try to relate what is happening at point number 2 here. Okay, because point number 3 is a continuity point that connect element 2 and 3. So let's draw point 3. Point 3. Okay, point 3 is having an external force in this direction. Okay, this is capital F, 3x. Okay, so there will be a force that counter this. There will be a reaction force at point number 3 that counter this external force. So the point itself will counter. The point itself will counter this 3f here. That's why we draw the arrow on the left from point 3. Okay. Then you back to this diagram on the left. So you have a arrow that pointing to the left. There is an arrow counter this one. Okay. So this one you label as f, small f, 0.3. Okay. 0.3 x. But 1, you have to label that this one is element 1. So we have done with this element. Then we solve for this one. So this one, because of this direction, so again, it must have an internal forces that act another direction. So this kind of arrow, sometimes I agree that is very confusing. It's very confusing whether it's going left or right, and it takes some experience to draw this one. So sometimes I admit that sometimes I make mistake also. All right. Now, whether this one will go left or right, it depends. So in this case, we assume that is having the blue color arrow, and this one will you carry forward to this one. Yeah. So this is the textbook explanation where you draw the arrow accordingly. Okay. So it will take some experience for you to plot this kind of free body diagram. But anyway, don't worry, you can solve it mathematically. Later we will use mathematics equation to help us to define the direction of the arrow. Okay, so this is just a estimation of the direction. Estimation of direction. Don't worry about this one. Okay. What we need to take home is that you have to know that all the points must be equilibrium. Means that all the force on that point itself, it must balance itself. Okay, it must balance. All the force at that point must equal 0. So in this case, we will know that F1x will equal to capital F1x will equal to small f 1x1 if you refer to first diagram. Okay. And then the second point here, F2x will equal to small f 2x2 because it referred to point number 2. Okay. Right. Now just a side note now. Now to draw this arrow, normally if there is a external force there, we will just follow the external force and put in element 2 here. Okay, so the element 2, if you imagine your element 2, then there's an external force that is going this way, there's this pressing point number 3, you will feel that there's a reaction force, not reaction force, you'll feel that there's a compression force acting on this point. Which is point number 3 here. If you're element 2, okay, if you're element 2, there's external force that is pressing on point number 2. You feel that there's a force that is pressing point 3. So you just follow the direction of these external forces. And then you complete the diagram accordingly. Okay. Yeah. So the general rule of thumb or the guidelines to draw this free body diagram is to look at your external forces. It will affect the direction of your arrow. So again, the first step, just to make things simple, first step you look at external forces and then you draw the arrow. So in this case, we draw the point 1 and point 2 first. So we're looking at the external forces, and then point 3, you draw the external forces, and then you expand it to either element 1 or element 2. So in this case, element 2, this point here, connecting point because it's react under external force F3, so the arrow will follow the external force direction. So you draw the arrow going in. Okay, and then on this side, because there's reaction force to the point number 2, so you just counter this force. Okay, a bit complex is this section because it's connecting 2 elements plus the external force. So my way of suggestion is that for the connecting point, always look at the external force first. You look at the external force direction, then you complete the right hand side arrow. You complete this arrow. Okay, then this arrow. But anyway, you can solve this mathematically. All right, so capital F3x equal to small f x plus small fx also, but it's a combination of 1 and 2. It's a combination of element 1 and element 2, which is this one. This one and this one. Okay, so your F3, this one, is actually a combination of element force, small f, that filled by element 1, and forces that filled by element number 2. Is a combination of these two. Right, now this equation is under the continuity requirement. Okay. Okay, can I? All right. Okay, try to as your homework, try to understand what is happening here. What is happening to all these arrow? Try to understand. So again, your test, I might be flip the direction of F3 here. I might flip to another side. So what happened to all this force? Okay, right. So all this arrow, so this one, this one, this one, this one is affected by this one. Okay. So the step of drawing the arrow is that you look at this one. Then you continue with this one. After that, you counter direction. You counter the direction at point 3. So you look at this arrow is the opposite arrow of this point. So you draw going up, going to the left. So this is step number 3. Then this arrow will counter this arrow. Okay, this arrow will counter this arrow. So point 4. Then this arrow connected to another one is another direction. This is step number 5. Okay. Or another method, another procedure will be, okay, you can do step 1 here. Then this point also follow the external force, because if you are this point under external force, you'll follow the direction also. So this arrow will follow the external force. So I will label this one as 2. This one also will follow the direction of the external force. I'll label as, maybe I'll label as 2 also, so that you can see the arrow of this one and this one will be the same direction of this one. Then you continue solving the remaining one. So this one will counter by this one. So you draw this arrow, and this arrow will counter this one. Then you draw number 4 or number 3. Okay, so this is the logic behind the arrow. Okay, just to refresh how you draw the arrow. First, you look at the capital F, external force. Then after that, you imagine you are the point. You are the connecting point number for element 1 and number 3. So because you are having an external force, so you are following this arrow. Okay, you are following this arrow. So what you do, you just copy the direction of the external force. This is step 1. Then you draw the arrow according to external force arrow. So if the external arrow going to the left, going to the right, then you draw going to the right. This one also go right. Then after that, when you solve for the connecting point for the element already, then you back to the point itself. You back to the point itself. Okay, you back to the point itself. Then you counter the forces of the connecting point. So I will write number 3 here to counter this one. Then this one will counter this one. Okay, this one will counter this one. So I'll label number 4. All right. So there are different type of forces here. You see that this is a small f. This is a small f. So this arrow below here is the external force. So I do not try not to combine the external force and internal force. Try to take them away from the internal and external, so that you don't confuse, especially when they are connecting multiple body. Okay. Clear, all of you? Brian, you okay?
Sir,
Yes.
what do you have to use?
Again, your question?
What do you have to use capital F when you're adding the two forces? When you're adding F3x1
You mean this
and
one?
F3x.
You mean this equation?
Yeah.
So you don't understand what is this?
What do you have to use capital F?
Okay.
Because it's an element, right?
Okay. This equation that I circle this one actually referring to this free body diagram. Okay. You are focusing on this free body diagram. This point number 3. So how many arrow you have inside this diagram? How many arrow? Brian?
2.
You are seeing 2? I'm seeing 3. 1, 2, and 3. Do you see 3 arrow?
Yeah, 3.
1 is external. This one. This arrow is external. This one. This one given by the question. This arrow. Then there are two small arrow here, which represent the element arrow. So to balance these 3 arrow, you just write in the equation. So if you write an equivalent equation, how do you, okay, let me draw point 3 here. Point 3, actually you have 3 arrow there. You have capital F, you have small f arrow. Okay, so let me label this one as 3. Yeah, maybe I write in a more simpler form. I label this one as B, this one as A. So how do you write all the force inside this system is 0? How do you write? You write, now all the force to the x direction is positive. So how you write to this force? You write negative FA. This one to the left is negative FB. This force to the right is positive capital F equal 0. You rewrite this equation. F equal FA plus FB. Do we see it now, Brian? Brian, are you seeing the explanation?
Yes, sir.
You understand why suddenly this one you can write f3x equal to small f3x1 plus small f3x2.
Yes.
Okay, nah? Okay, Ashma, you able to understand?
Yes, sir.
Okay, nah? Chia, Sue.
Yes.
Okay, good. Okay, so we're going to continue. A few more slides, then we end the lesson today. Huh? So you have 3 equations, 1, 2, and 3. Okay, recall the shape of the equation just now. You have 2 equation, two matrix there just now. Yeah? So you have f1x, 3x. This is the for element, first element. The one on the bottom right is for element number 2. So what you need to do now is to combine everything. Huh? So f1x equal to k1u1 minus k1u3. You derive from this equation, this matrix. So f1x equal to this one times this one plus this one times this one. You get the first equation here. You do the same for the rest. You do the same for the rest. You have 4 equations here. You have 4 equations. So I'm writing the first one for you. Right? f1x equal to k1u1 minus k1u3. Then f2x you derive from here. This one, f2x minus k2x times this one plus this one times this one. Okay, then you get the second equation. f3x is a combination of this equation, f3x equal to this row times this column. So you take this one times this one plus this one and this one. So you get the first one. This is from here. And you have a second element, which is this one. This one equal to this row times this column. So again, you take this one times this one plus this one times this one. You will get second equation. Okay. So this is a matrix. How you extract from matrix into equation. If you don't know, go back to Appendix A that I upload already in the Moodle. Go and read. Okay. So you have 3 equations there. Now you only need to put them into a matrix form. Okay. You put everything in a matrix form, you'll get this one. Okay. Now, how do you write matrix form? You write 1, 2, 3, meaning force at point 1, 2, 3 because you have 3 points there. And then on the right hand side, actually it's from F equal to KD. Okay. Sorry, I should use the small f. F equal to KD. And then you write all the force according to the 3 equation here. So F1x here, okay, back to the equation. Because F1x just now is equal, F1x just now is equal to capital F1x based on the free body diagram that we draw just now. Okay, same with small f3 and small f2x here. Okay, same, you convert to the capital F there. Okay, the rest is just mathematical steps. What I need to help you is that you see matrix as a parking lot. You need to park your number accordingly. My way helping you is to use your pencil to draw, to write the number that you see on the screen here. I'll write as 1, 2, 3. 1, 2, 3 mean that this is 1, this is 2, this is 3. And then I will park my number accordingly. So the second way, the second step is that you break your matrix into 3 times 3 matrix because you are having three unknown on the left. You have 3 unknown on the right. Normally, you will need 3 times 3 matrix to balance this matrix. Okay, you look at the left hand side, you look at the right hand side, you count how many number, then you roughly estimate the shape of the matrix. This is 3 times 3 matrix. Okay, then I will continue explaining how you park your number. Just pay a little bit more attention. Okay, so this is 1, right? Element 1, you are writing K1 U1. So how do you derive this equation? You actually deriving equation is K1 times U2 plus 0, because if you look at equation number 1, there's no U2. So basically you can write anything that is 0 times U2. So what you do is that you write 0 here. 0 times U2 plus negative K times U3. So you write K negative times U3. Clear, everyone? How you park your number? Or you can just label 1, 2, 3, 1, 2, 3. Just not to confuse yourself. It means 1, 2, 1, 2, 3, row 1, and you park accordingly. So for example, this number is element 1. This is element 1, all the number in element 1. So you park your K1 here accordingly. So how you write? So this one is K11. This is K13. This is K12. So this is K11, K12, K13. You park accordingly your K. All right. Then the rest you just copy accordingly, right? You just follow accordingly. You derive for the second one. You continue with the second equation. 0 times U2 plus this one. Because here you don't have U1, so you just write another one. 0 equal U1. So there's no U1, so it's 0. It must be 0. So you write 0 here. 0, K2, U2, K2, U2. So K2 times U2. K3, K2 negative. So negative K2 times U3. Basically, is if you look at the F2 second row, it means you take the second row times this column. If you look at number 3, then you look at this column, this row. You take this whole thing times this one. Now, what is the area of mistakes done by the student previously? Is this one. They don't know how to combine this one inside matrix. So if you expand this equation, or you simplify this equation, you will get the same for the U3. So you're having a 2U3 there. You have a K1 U3 plus K2 U3, which you can write as a factor, factorize it, K1 plus K2 U3. So this one you put here. Clear, Ashma? Ashma, you understand?
Yes, sir.
Okay,
Yeah.
good. Any one of you don't understand why suddenly this one you're seeing K1 plus K2? Can all right. So this is the matrix form that looking for. So if you compare the general equation, capital F equal to KD. So your F equal to this one. Your F equal to this one. We call it global force matrix. D is 3 displacement there. U1, U2, U3. and this is your K, global stiffness matrix. Now today we're going to look at general 1, 2, 3 and the K, F, and the alphabet letter. So when it comes to your test or as final exam, all these numbers were given a value. So you need to substitute all this value and calculate the value. All right. So with this, we end our lecture today. Let me end the recording.